But yeah, today I will talk about how to build an AI assistant, and the topic of today is called From Idea to AI Assistant. My name is Ivan. I'm AI engineer at Hyperskill, and let's get started. So, okay, so plan for today. First, we'll talk about assistants in real life. Then I will give you a couple of theory sections, which is, I think, which will be useful for you to know. And we will end with building an actual AI assistant with some fancy tools. At the end of each section, we will have Q&A. And so if you want to ask me a question, you can always use Zoom's Q&A feature. Feel free to ask me. Okay. Now, let's talk about assistants. So have you ever interacted with an assistant? Maybe when you first think about it, you will not remember anything, but actually there are a lot of them all around us. Starting from Notion AI Assistant, which helps you to write some kind of documentation and brainstorm ideas, to Windsurf Coding Assistant, which helps you to write code, to Alexa, who interacted with you in a natural way and talks to you about weather, about, I don't know, how are you today, and so on. So assistants are actually everywhere. Despite different appearances, there are one thing that is common. Actually, three things that are common. So for me, an assistant is something that can engage in a natural conversation, knows relevant context, and can solve some problems. So for us to implement an assistant, we will use an LLM, large language model, to simulate a conversation. We'll figure a way how to add knowledge to our system, and we will implement some basic mechanics for the model, not just to act, not just to speak, but actually to act. Okay, but first, by the end of today's webinar, we will implement a simple assistant. We'll give it a personality. We'll provide it with a knowledge base, and we'll see how it can use it. We'll try to add some tools allowing it to act. And if we have some time, we'll maybe embed it into a website. Okay, so let's switch to the theory. Forward before a theory. You don't need to understand and remember all the theory I will share with you today in order to build your own assistant. I'm doing this because I want to give you an intuition of mechanics and mechanisms that are lying underneath the common interface for you to understand how it is happening under the hood, maybe make some decisions of how you will build your assistant based on this information. So don't be afraid to feel lost at some point. You can always ask a question, or you can wait for the second part, which will include a live demo, and you'll see that building an assistant is not actually hard as it might seem when I'll explain the theory. Okay, so I hope it's okay for everyone. Let's take a deep dive into theory. Okay, LLMs 101. What is the typical workflow of someone interacting with a large language model? It is actually, we will select a provider, we will send an input text and get some output text. The common thing between all of providers is a large language model that is hosted somewhere in a cloud and interacts with us. But actually, there is a question of how does model understand the text? Because model is basically a mathematical function that converts one input sequence of numbers into another. And what it does is just performs a bunch of linear and nonlinear operations. So it have no idea about what text is. So to work with the text, we need to introduce two concepts. First concept is tokenizer, and second one is vectorizer. Tokenizer actually translates input sequence of characters into sequence of tokens. It might not be so obvious why do we need this tokenizer right now, but I'll talk about it later. The second concept is vectorizer, which takes a sequence of tokens, not characters, and translates them into vectors. And then we'll take a bunch of vectors, pass it to a large language model, it will output another bunch of vectors. So how do we translate these vectors to text back again? It is actually quite simple. We do inverse of these operations in other order. So we'll first translate vectors to tokens, and then we'll translate tokens to characters. Okay, more things about tokenizer and why it is important. So tokenizer allows you to save computational resources by combining sequence of letters to single tokens. Think about it as squeezing a set of characters in just one ID, in one unit of data. I'll give you an example. So if we want to use tokenizer, then for us to pass some text into a model, we will need 8 vectors for each of the characters and one space. And these kind of operations to translate this text through a model. On the other hand, if we will use tokenizer, then we can just combine characters in that we can just combine our full text in just 2 tokens, and it will save us a lot of computational power. Actually, this example is not very correct in terms of vector size, but it is correct enough to be shown as an example and as a reasoning. So, for the purpose of today's lecture, I think it will be great for us to stick with this kind of abstraction. So we will not think about vectorizer, we will just think about tokenizer, as that all our interaction with LLM is going through tokens. So we will have an input text translated to tokens and send these tokens to an LLM, which will output sequence of tokens. Why tokens are actually so important? Because if you have previous experience with LLM, you may notice that nobody is giving you like prices or model size in terms of characters. Instead, everyone is talking about tokens. So here are just some screenshots from top tier LLM providers, and everyone is talking about tokens. So token is a universal unit of pricing, and token is a universal unit of model capacity. Okay. Key takeaways from this section. So tokens, not characters, are the main unit of pricing. LLM operates on vectors and matrices, not characters, and text is translated into vectors with tokenizer and vectorizer. Do you have any questions so far? I'll give you just a couple of secs if you haven't have time to write it. Okay. No questions so far. Okay, let's move on. Oh, yeah. Okay. Okay. Okay, let's move on. Dialogue system with LLMs. So we will not just now we will talk about not just how to interact with one message, but actually with a set of messages. Here is a simple dialogue that may occur between user and a model. So what is the size of an ocean? I need to clarify, are you talking about world ocean or specific one? The Pacific, got it, and so on. So how is this conversation actually happening? First, user types his message, sends it to a model. Model responds with an answer. Okay, then user responds with another message. And now model somehow gives it an answer, but how does actually the model know what was the initial question? Because see, LLM doesn't have any memory. So it doesn't remember previous conversation. It doesn't like write down all the things you have written to it. And to simulate a conversation, model providers give us a very clever, simple, but yet effective trick. I'll show you this trick right away. So, okay, let's go through this whole dialogue once again. So what's the size of the ocean? LLM response. Then we want to send another message. And what is actually happening underneath is that not just the last message is sent to a model. Instead, all previous messages, the whole previous dialogue is combined in one kind of huge message and sent to a model. And this is how model can remember the previous conversation. One more useful trick that we need to add to this dialogue is you may notice that usually bots or assistants kind of have personality. And where this personality comes from? It's coming from a thing called system prompt. It is usually hidden to an end user, but it is shown to a model as a message number 0. So, for example, each conversation with a large language model is actually starting with this system prompt, and only after it, the real conversation with the user starts. Okay, now let's recap what I told you about in this section, is in previous section, and put it all together. For example, we'll simulate a dialogue and how tokens in this dialogue are used. So we have system prompt, 200 tokens, user message 50 tokens, large language model 80 tokens. And on the right, you can see example size of a text, which is about 50 tokens, just for you to understand what kind of size of a text. Okay, now let's simulate how these prompts and messages are sent to a model and count number of tokens. Okay, so to start our conversation, first we'll send system prompt to large language model, and it will output us a first LLM message. For example, greeting, hello, how can I help you? My name is blah, 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 and so on. The next thing, when user adds a message, we concatenated the whole previous conversation and send it to a model once again to produce the second message. And it goes on and on. So when user answers one more question, the dialogue that is sent to a large language model is getting bigger and bigger. So you may imagine by 20s that were 20 messages in a conversation, the percentage of actually your last message among all other tokens that are sent as an input is getting smaller and smaller and smaller. And this thing is a thing to remember and to understand. But don't be actually too afraid. Here's why. So here is the pricing for models. GPT-4o, GPT-4o mini, with this kind of standard model to build an assistant on. And it has a pricing of $2.5 for a smarter model and just 15 cents for a stupider model. And this price is for 1 million tokens. And for comparison, 1 million tokens is about 9.4 novels. So this is a thing not to be afraid of, just a thing to remember. Okay, key takeaways from this section. LM doesn't have dialogue memory. To simulate a conversation, full text of previous dialogues is fed into a model, and a tool to give LLM instruction about how to behave, set conversational tone, describe rules, etc. is called system prompt. Okay. I see a question in the chat. Do LLM message mean output message here? I'm not sure I fully understand the question. Maybe you can rephrase it? What is the difference between system prompt and developer prompt? The difference is naming. At some points of a time, OpenAI, which was like a first one who introduced this naming, started to call this prompt developer prompt or system prompt. Nowadays, standard is we have system prompt that describes overall behavior. We have a user tag that is linked to a user message and a system tag that is linked to a model message. So developer prompt is not used actually right now. What is LLM means? LLM is a large language model. So it is a huge neural network built on top of transformer architecture that translate input text to an output text. You can think is a great example of a large language model is ChatGPT, so which is a large language model under the hood. Okay. I mean the output given by LLM based on an input prompted is called LLM message or not. Output given by LLM. Okay, so the message that LLM outputs is called an LLM message. So sorry, I don't get it. Yeah, sorry. I'll skip this question. Maybe I'll answer it later if the thing will hit my mind. Okay, any more questions? Oh, yeah, there are way more questions. Will it be more useful to additionally specify system prompt in very first message to assistant? For example, system prompt, answer as expert Python developer, user prompt, write some my function. So you mean like we will send system prompt before each before each message. It will okay, let me. You mean we will add this system prompt like here and like here. This is also maybe an option, but nowadays LLM are trained so good to remember system prompt and not to forget it during the course of conversation that this is maybe just a waste of tokens. So system prompt is a preloaded input to create this personality and boundaries to have a conversation with the LLM that can be configurable. What is the boundaries of conversation with an LLM? What do you mean? It's like a size of input tokens, size of a text that you can send to LLM. If it is a question, then yeah, all models have a size of maximum number of tokens it can process. So, for example, in one of previous slides, it was Claude model that can process 200K of tokens at once, and this might be like a top limit for the model to process. But actually, there are some hacks to get around it, but I will not dive into it. Okay. Mm-hmm. Okay, I guess. Ah, you're talking about how we can filter what is model talking about, and like, for example, can it talk about guns or not? If so, that there are two things to consider. First one is how the model was trained initially. So like models like OpenAI models or Claude models are safe by default. So they are trained to get rid of sensitive material and to get rid of sensitive talks. But we also can specify what things are not to talk about in system prompt, and it will also work. Why models start to hallucinate after a certain amount of tokens context in broad terms? Models start to hallucinate because okay, first we'll have a bit on hallucinations later, and models start to hallucinate because of the way the model are trained. So how model is trained under the hood? It is trained to predict the next token. So for like in our previous dialogue, it was meant to predict the next message that goes after the dialogue we send it to. And in terms of like human conversation, the last parts of conversation are way more important to predict next token on compared to the very first one or some things that were in the middle. That's why when context window is growing really, really big, it is more efficient for model to remember to give more attention to the things that were told like in nearby past than to the things that were told like in far, far, far away ago. I hope it makes sense. Okay, I think we should go further because yeah, because we have a lot of more material to cover. Okay, now let's switch to the fun part. How to build an AI assistant. Quick recap of what do we expect from assistant. So we needed to engage in conversation in a natural way. We needed to know relevant information, and we needed to solve problems. And okay, I wanted us to build something fun, So today, what we are building is we are building a virtual Alfred, who is Batman's butler, and we'll try to play around it. We will build it in a tool called Defy. I love this tool because it is quite a simple way to get started with like real large language models, real assistants. It is still simple enough. It encapsulates a lot of hard things, and it's just fun and looks good. So let's jump right into it. And here is our Defy. Here is our Defy window. Let me check if you see it correctly. Yeah, you should see it. Okay. Okay, so what I have already done is I've created an assistant. It's like a template assistant. And let's start to talk about it, to do something with it. So we have an Alfred. We want it to be some kind of a helpful assistant. Okay, so we need to write and extract instructions for it. This is basically the same as a system prompt. Okay, so you are Alfred, a helpful assistant. Okay, helpful assistant. Let's try to, yeah, okay, everything's turned off. Let's try to talk with him. Hi, how are you? Okay, he just responded. What can you tell me about herself? Yeah, so it's an AI assistant. It have his trained data based on October 2023 because we are using GPT-4o mini model. And actually, this is kind of bland, super bland assistant. It's nothing interesting. Let's give it a bit more personality. Let's make it more like Alfred. So I have prepared prompts. We will use this one. I want to become a Batman once upon a time. So to do so, let's give Alfred a more fancy kind of instructions. Your more personality. Let's try it again. Okay. Hello. How are you? Yeah, this is more fun. Okay. Now, let's switch back to Miro and we'll do something helpful. So do something not helpful, but interesting. Okay, so as I said previously, we want to model to know things about things. For example, if we will ask Alfred right now what the weather was on 5th of March in Barcelona, then he will produce us some kind of hallucination. Actually, let's try it. So we have Alfred right here. Okay, what was the weather on 1st of in 2025? Yeah, so he doesn't have any idea of what the weather was like. But for us, it's kind of a natural thing to expect from an assistant to know relevant things for us. And this is not just about the weather, it's maybe things about how to implement feature X in our proprietary code base. What do we have on menu in this exact cafe, and so on. And the problem is trained model doesn't know anything about our cafe and probably will not know at any point of time, because models are trained on such huge amounts of data that some kind of specific details about a non-important cafe somewhere in the suburbs of Barcelona will not be remembered. So we need to implement some kind of a mechanism for a model to know things and to produce a reliable results. Okay. Yeah. One simple solution is just, why don't we put all the information that we need in a system prompt? Because we know that it works and it actually makes sense, but there are quite some problems. And the problem is, first, it is hard to update information. Second, it may become pricey. Remember that for each message we send to our model, we also send a system prompt. But if our knowledge base, it's not, if our knowledge base is not just a couple of paragraphs of text, but it might be huge. It might be 9, 10, 12 novels in size. Then it will be a huge cost to process each user message. And finally, all the information may not fit inside the model context, because there is an upper bound of text that model can process. So the solution is called RAG, Retrieval Augmented Generation. I will not go deep inside how it works. I'll give you a basic overview and kind of intuition behind it. So, for example, we have our initial huge knowledge base that we want our model to know. To process it, we split it into chunks. For example, for a menu, it may be that chunk 1 is about coffee, chunk 2 is about milk, and so on. So, to answer questions about our database, we take user input and try to find a relevant chunk that might be relevant to the input message. Then we will take the most relevant chunk and just put it in our prompt, kind of the same way as if we put it all our database in our system prompt, but instead we just put a simple small chunk of text and it will work. Yeah, it will work. Okay, pros and cons of RAG. So yeah, it allows you to work with huge data sets. It allows to use data previously unknown to a model. It reduces LLM token usage, but it's not a silver bullet. Sometimes it's not so easy to implement, and 100% quality is not guaranteed, and actually is almost impossible to achieve. So for example, the main point of failure of RAG system is incorrect retrieval. It is the thing I told about here. So there is quite a probability that our RAG system will not find a chunk that is actually relevant to an input. But still, RAG is a very useful thing to use and to try. Okay, now let's try to edit in our Alfred bot. I'll switch back to DeFi. In DeFi, we need to add knowledge. Okay. Okay. Uh, DeFi is quite a new product, and they just released the major update a couple of days ago. So there are still some small bugs and things that can go wrong. So it's happening. It happened. Okay. Um, what do we want from our Alfred to know is to know things about what is kept in Batman's arsenal. I already generated kind of a catalog of what is inside Batman's cave, and we'll play with it. Okay, I will import it from file. Here we are describing how our initial huge data set is split into small chunks. Because my initial file is in Markdown, I'll split it with this symbol. We can preview of chunks. Actually, I guess it makes sense. Like, okay, here is Batmobile technical specification headline. This is details of Batmobile, and so on. There are another details here. I guess this one is important one. Top key in vector search. Remember that on a picture I showed you that just one relevant chunk of text is put into system prompt. But actually, to boost our performance, to boost performance of our system, we cannot just put the one relevant chunk. Instead, we can put a number of relevant chunks. So for example, top key here is 3, meaning that 3 most relevant chunks are put into a prompt. It is still not the whole data set, it's just 3 small chunks, but it will increase the overall quality of our system. It's like a lot. Okay, so we'll save this knowledge base, call it Batman's Arsenal. Let's call it 2. And no, we will not call it number 2 because it already saved a name some way. Okay, we'll switch back to our Alfred. Okay, it forgot everything that we told him. Not a problem. Let's add our knowledge. Let's copy and paste the prompt once again. Okay. Okay, and we'll add to a prompt things like if there is a question about Arsenal, use a knowledge base. I hope it will now save changes. Okay, let's try it. So, hi, what tools do we have to capture Joker? See, now it is not producing an answer based on its own memories, on its own data that it was trained on. Instead, it uses a knowledge base that we give to it. Yeah, so look, it like queried to search for relevant chunks, and here is like one of the chunks that were returned by a knowledge base. Okay, yeah, and it shows us which knowledge base it actually uses. Okay, now let's go back to questions. Yeah. Okay. Um, what are the skills needed for the job in AI deep learning after Python? Uh, it's quite a huge question. Um, so there is, I guess it will be a useful information for you in the end of today's lecture, and I hope it will give you a clue of things where to look for at least. Okay. Uh, Which template was Alfred started from? Um, it wasn't started from any template. Um, I just said it wrong. It was started like this. So I just go into agent, create from blank, selected agent, and typed a name and description. So there were no actual template. Um, if an LM doesn't find a relevant answer from chunks, does it move its pre-trained data? Yeah, it's a very good question. So, what is actually happening if a model doesn't find a relevant chunk? Sometimes it will hallucinate. Sometimes, if we put this in a like system prompt that works with knowledge, it just said, "Sorry, I don't have enough information to answer your question." So there are different scenarios of how you can implement it. Um, okay, hope you talk about how to filter a prompt. For example, if an agent is for chemistry, how to manage it doesn't accept answer questions of other field. Um, to filter prompts, not to answer questions from other field, you can just type it in your system prompt. To further ensure that it will not answer questions from another field, you can fine-tune a model, but it's kind of advanced concept. For example, I can show you. Let's try to ask Alfred about Gotham City. Okay, so how? Mm, okay, do you like Gotham City? Okay, okay. So he doesn't. So he gave us an answer about Gotham City, but now we wanted not to talk anything about Gotham City. Okay, you are prohibited to refuse to answer. Okay, let's try it once again. Do you like Gotham City? Look, so now it just ignores and try. He just avoids talking about Gotham City. I hope it gives you an answer to your question. Okay, which of the questions am I missing? Do you need to tell the LLM to search in Iraq on the system prompt? It is actually a very good question because it depends on an architecture you're using. So, for example, as we are using GPT-4o Mini, there is actually kind of sophisticated prompt that already includes all the information. I mean, that is okay. Let me start over again. So when we are using GPT-4o, every message that model processed returns as an output either an answer or a thought about if a search for context should be performed. So yeah, this kind of implementation issues. So in a simple answer, yes, you will need to add you will need to add rules about that you need to search in a knowledge base for a simple model. But in case of GPT-4, you should not. It will be already handled by OpenAI. Okay. Can PyCharm be used as an IDE to build an AI app? Sure, sure. I'm showing you a DeFi because this is like a simple no-code solution that doesn't require any coding skills to use it, to try. But in the real world, yeah, PyCharm is an IDE that you can write Python code, for example, and with Python code, you can write an AI app. So in my own experience, I use PyCharm to write code. And yeah, so I'm creating AI apps with Python through PyCharm. Oh, maybe I missed this question. When the dialogue is too big, does agent resends the initial system message? Um, what is happening inside is like summarization of what was previously told. Like, so the mechanism, for example, in OpenAI is that we have system prompt, we have our previous dialogue, and we have the new message that is just about to be sent to a model. If all these messages combined are getting really big, then another model takes everything from a middle, like tries to summarize it and to extract key point, then removes this big part and put a summary instead, which now shrinken the context by a huge amount, and this will be sent to a model again. So yeah, system prompt, if I'm not mistaken, will not be touched. Conversation dialogue will be touched and will be summarized, and the last message will not be touched. Okay, okay, okay. Let's move on because there are one more cool things to one more cool thing to explore. Okay, okay, okay. So now we will be talking about how to make a model do things, because an LLM doesn't actually have any hands to perform any real-world tasks. But there is once again a trick that is used for a model to do things. So, okay, if we want a model to like sum two numbers, we can add to a system prompt a description like, okay, if there is an intention of a user to do something that you don't understand or don't know how to do, then you can use this function. To use this function, you need to provide it with some input data and expect this as an output. So when a model will see this kind of text and this kind of like tool description, it will not try to hallucinate. Instead, it will do things like, okay, so I think this is a situation. So this is a situation where I need to use this tool. So instead of outputting a text, I will output a structured JSON file or XML file, so structured output that contains data according to description, and then not LLM will perform an operation. Instead, our code that we previously written and previously implemented will execute this operation. So not LLM will do calculation. Instead, some function like real function from real code base will be called in order to process the input. It will produce an output, and this output will be sent to an LLM that it will form an answer. I hope it makes sense for you. Do you have any more slides? Yeah. So tool calling. So things to remember here. LLM doesn't do things. To perform a desired action by an LLM, you need to implement this action, and to use it, LLM will not use it directly. Instead, it will give you like an output and parameters that you need to take yourself, put them into your model, into your function, process this function, and return the result back to the model. Let's try it in DeFi. I hope it will make much more sense there. Okay. Back to our Alfred bot. So let's try a simple addition task. Let's ask a model. Okay, what is 2 plus 2? And the model will give us a correct result, because 2 plus 2 is an actual thing that is usually usually written in text somewhere over the internet, but our model will not be able to process something way more advanced. For example, what is plus? Okay. And meanwhile, we process it ourselves. Actually, it's kind of fun because model gave us a correct result. We can try again to see if it will experience some hallucination or not. No? Okay. It's fun. So basically, models are bad with numbers, but somehow this exact combination of numbers is good for a model. Let's ask it to do something more way advanced. For example, divided by Okay, let's try it. No. Okay. And here we go. Now we can see that the numbers are actually different. So here is a real calculation done by a real calculator. And here are calculation done by a model. So this is actually a hallucination. So what do we want to do is we want to get rid of this hallucination. To do so, we'll introduce a tool that allows us to make calculation for us. Here are just implemented functions that were actually implemented by someone and provided a very convenient interface for us to use. Let's reload the bots and try to send it the same data again. Look, now it is using the tool and it will give us a correct result. Yeah, result is correct. So let's look into details of what is happening in function. So now it takes a math expression as an input. We can see it. So LLM, I need to give another example. So what is divided by 65? I wanted to show you that model is getting rid of any access data that is happened in message. It just uses the data that is specified by prompt of this tool, like right here, and produce an structured output, which is then translated and which is then given to our Alfred bot. Okay, now let's do some more fun stuff. So math is okay, but we actually want our Alfred to know some things about finances, because Bruce Wayne is like, he's a billionaire and he have some money and he invested it. For example, we also want Alfred to know time. Look, for example, if I disable time and I'm like sitting in the Batcave and it's way too dark outside and I don't know what the time is, I can ask what the time is now. Yeah, so Alfred doesn't know what time is now, but if we will add the tools that can know what time is now. What time is now? Yeah, it now uses a function and gives us the correct time. Time is a fun function because it doesn't have anything as an input. Instead, it just produces an output. So this kind of function is also a valid option. Okay. Now I think I'll go back to my presentation. We'll go through some more slides. And then maybe if we'll have time and you have ability to listen to me some more time, I'll show you how to embed this assistant into your website. Okay, so takeaways from this part of this part. So to define assistant personality and behavior, one may use system prompt. To allow assistant to interact with your knowledge base, you should use a RAG or knowledge base system. And tool calling is not magic. It's just an LLM telling your system what function to call and with what parameters. And I guess that's all for today. Now you can send me more questions if you have. And I'll show you meanwhile the next slide. So someone asked me where to learn about AI or other AI related stuff. We are launching an AI engineer bootcamp. It will take 8 months to, it will last for 8 months. So here is a QR code and a promo code that you can go to and see if it is suitable for you. Okay, any questions so far? Because I don't see any questions. Great webinar, compliments to the chef. Thank you. It was a pleasure. Yeah. Thank you very much. It means a lot to me, really. Tried QR code. It's not currently working. A problem at my side. Let me try it. I thought it works for me. Sorry. So guess problem is on your side. Yeah, here is a link in chat that you can click on. Okay, so I guess we are ready to finish. I can just show you like 2 minutes how you can use this assistant in your site. I'll show it. I show it to you really quick. Okay, so DeFi allows you to ingest your code. First, we need to publish it. Yeah, it's published. And then we go to embed into a site, select the one which is more suitable to you, copy it, and we are using Webflow, which is kind of a standard way to host a landing page nowadays. We can just go to description of our site. Where is here? Where is it? Here. Copy paste code. Okay. Click publish. And in just a few seconds, our bot will be available on the website. Here it is. Okay. It's called CoffeeBot because this was a previous name of an Alfred bot, and this is one of the things that is happening when you are using a startup product. Okay. Now, I think that will be it. So I'll leave you with this slide for some more time if you want to, and I'll say goodbye to everyone. So goodbye, everyone. Thank you very much. Bye bye.